Yeah, so good evening, class. So this is called solvay process, the scheme chart diagram representing a solvay process. And in this case, the major aim is to come up with soda ash. Soda ash is just but sodium carbonate. That is its chemical name. The chemical name of soda ash is sodium carbonate. And of course, to start with, then we begin with the raw materials. The raw materials for this solvay process are, they include the following. The raw materials for this process include the coal. We have coal. We also have coke. And we have limestone, or chemical name of limestone is calcium carbonate. So we also have limestone or calcium carbonate. All these three raw materials are going to help us generating carbon 4 oxide. So these are going to generate carbon 4 oxide, and they generate carbon 4 oxide this way. When you burn coke, which is just but rich in carbon, so it can be a coke or it can be a coal, a substance that is rich in carbon. Then when it is burnt in presence of oxygen, it gets oxidized. It gets oxidized to carbon 4 oxide. So we are going to have carbon 4 oxide gas. We are going to have that equation. So carbon 4 oxide will be produced based on that reaction. And this is just an oxidation of what? Coke and coal. We can also produce carbon 4 oxide by thermal decomposition of limestone. And we can generate carbon 4 oxide this way. Yeah, so we have limestone being strongly heated. Strongly heat this, and of course it is going to decompose to carbon 4 oxide and calcium oxide. And calcium oxide based on this equation. So in this case, both the first two and the last equations are generating carbon 4 oxide. They are generating carbon 4 oxide. Now these three equations, or the generation of carbon 4 oxide, usually occur at chamber 4. It occurs at chamber 4. So these are the reactions that takes place in chamber 4. So in chamber 4, we are having the coke, we are having the coal, and we are having the limestone, which is being burnt to generate carbon 4 oxide. And now we can see carbon 4 oxide being produced, proceed to chamber 3, proceeding to chamber 3. Now in this case, our chamber 4, for that matter, is called the kiln. This chamber 4 is called the kiln. Yeah, we call it the kiln. That is where there is combustion. Now, more other raw materials for this process. Include water. Yeah, they include water, and we still have brine. Then we have ammonia. In this case, we have ammonia. Yeah, we still have ammonia, and in this case, still have ammonia gas. And ammonia gas is just from our source. So we have two sources of ammonia. We have ammonia from the source, and we have a recycled ammonia from chamber 2. So this chamber 2 also produces a regenerated ammonia, but in this case in solution form. So it is called ammonium hydroxide. So we have ammonia in solution form, ammonium hydroxide. I think we are together. Now the next thing is to talk about chamber 1. What is happening in chamber 1? Because all begins in chamber 1, where in chamber 1 we have brine that enters in chamber 1 and mixes with ammonia from the source, and the other ammonia from the recycled ammonia from chamber 2. So in chamber 1 we just have physical mixing of ammonia and brine. So here we have brine and ammonia. We have brine, and of course the chemical name of brine is concentrated sodium chloride. Concentrated sodium chloride is made to mix with ammonia. Ammonia. So the two forms a mixture. By the name ammoniated brine, and the mixture proceeded to chamber 3. So ammoniated brine proceeds to chamber 3. So we have ammoniated brine as the product formed when a mixture of ammonia and brine combined in chamber 1. So we are going to have ammoniated brine, and of course the mixture now proceeds to chamber 3. Now for that matter, our chamber 1 is called the first absorption tower. So our chamber 1 in this case is called the first absorption tower, and so we call this first absorption. Then we have the reaction proceeding to chamber 3. Now in chamber 3, we are going to have ammonia from the mixture, ammonia in form of ammonium solution, ammonium hydroxide. So ammonium in the mixture, which has come together with brine, which is just but concentrated sodium chloride, and of course there is carbon dioxide from chamber 3, which we have said is called the kiln. So in this case, we are going to have carbon oxides, and of course we are also going to have water from the roaster. We are going to see how the water in the roaster is formed. How the water in this roaster is usually formed. So we usually have water from the roaster. So we have water here. Now these two are going to react. They are going to react in two-step reaction process. And in this case, the first step, that is chamber 3. In chamber 3, we are going to have the two-step reaction. And the first step is the reaction between ammonia, let's write it in gaseous form, ammonia, carbon dioxide, and water. Let's assume it has not yet dissolved, it's still in gaseous form. So we are going to have this reacting that way. And now the product of these three substances reacting will be ammonium hydrogen carbonate. Now ammonium hydrogen carbonate is just but in solution form. Then there will be the second step reaction. The The second step reaction in this case will be now the combination of this product, ammonium hydrogen carbonate, with brine. So it is now going to react with brine. It is now going to react with brine. And in this case, we are going to have an ion exchange reaction. We will exchange their ions as they react. So what we are going to form will be ammonium chloride, and the other one will be what? Sodium hydrogen carbonate. Sodium hydrogen carbonate, and both of which are in solution form. They are in aqueous solution form. They are in aqueous solution form. So these two liquid mixtures, so these two solutions were formed here. One of which usually quickly crystallizes, and in this case, sodium hydrogen carbonate quickly crystallizes at low temperature. On slight cooling, we are going to have sodium hydrogen carbonate forming some crystals. In other words, it changes to solid, so it forms some crystals. So the next step here, when the four substances react, then there will be a cooling. There will be just a cooling before the mixture leaves. There will be a cooling. So when the cooling is done, sodium hydrogen carbonate crystallizes. We have said sodium hydrogen carbonate crystallizes, and of course it forms some crystals, so it changes to solid. And now we will be having a liquid solid mixture which can be separated by filtration. So the mixture proceeds to the filter, and now it will be easy to separate the liquid mixture by a process of filtration. So we filter the mixture, and in this case we are going to have sodium hydrogen carbonate as residue. Sodium hydrogen carbonate as residue, which will proceed to the roaster, while ammonium chloride will remain in solution form, and it will proceed to chamber 2. That's why you can see two arrows here. Now these arrows represent the pipes on that particular reaction chain process. So these are just the pipe leading out sodium hydrogen carbonate, and this is the other pipe leading out ammonium chloride. So ammonium chloride will just be collected. It will proceed to chamber 2, while sodium hydrogen carbonate will proceed to chamber to the roaster. So what follows next is the reaction at the roaster. So what is happening in the roaster? Yeah, from the word roaster, we get roaster from roasting. That means we heating a substance strongly. Yeah. So in this case, when you roast or when you strongly heat sodium hydrogen carbonate, then it gets decomposed. We are decomposing this substance by heating, and in this case, we are going to harvest sodium carbonate, and carbon 4 oxide will also be formed, not leaving behind water. Water will still be produced. So in this case, this reaction involves thermal decomposition of sodium hydrogen carbonate with the aim of coming up with sodium carbonate, which is our soda ash. So the sodium carbonate will now be collected down here. The water being formed will be recycled, and this is how it is recycled, by following that arrow. So it proceeds and combined with the other water from the water source, ready to be recycled. So it will be ready to be recycled. Now, carbon 4 oxide from the roaster again proceeds to chamber 3. Sorry, this was supposed to be carbon 4 oxide. So carbon 4 oxide proceeds to chamber 3, and in this case, that is also a form, another way of recycling carbon 4 oxide. So both carbon 4 oxide and water are recycled. They are recycled. Yeah, we recycle both water and carbon 4 oxide. Now, yeah, in this case, our chamber 3 is also called the carbonator. So this is our carbonator. Chamber 3 is carbonator. Chamber 1 is first absorption tower. Chamber 2 is second absorption tower. Chamber 4 is the kiln, where there is strong heating. So let's see what happens. What happens when after decomposition of limestone? After decomposition of limestone, something to note after decomposition of limestone, because we have said limestone can be decomposed by heating to generate carbon 4 oxide and calcium oxide, which is quicklime, is also being produced. So as this carbon 4 oxide proceeds to chamber 3, calcium oxide or quicklime proceeds, it is harvested down here. That this is the arrow leading out calcium oxide, where it is made to combine with water. And in this case, this combination or this reaction will take place at the slacker. So what will happen is that at the slacker, there is a process called slaking, and in this case, slaking involves chemical combination of water and calcium oxide, and this is how they react. So calcium oxide in this case dissolves in water to form calcium hydroxide. It forms calcium hydroxide. In this case, it forms calcium hydroxide, which is just but a solution. My questions are not balanced because they are just but in their correct state symbols. So that is just but the summary of what happens at the slacker. The process is called slaking. The process of dissolving calcium oxide in water is called slaking. It's called slaking. So you can slake calcium oxide in water, and that is the product, calcium hydroxide. So what will happen when you form calcium hydroxide solution? Then you can see it proceeding to chamber 2. It is going to follow this pipe shown by the arrow, and it will proceed to chamber 2, where now in chamber 2 we are going to have calcium hydroxide, which is now going to chemically combine with ammonium chloride. So let us see the reaction in chamber 2. Let us look at the reaction in chamber 2. What will happen in chamber 2 is that there is a reaction here. There is a reaction between ammonium chloride and calcium chloride. So we are going to have ammonium chloride and calcium hydroxide. Again, they are going to react in chemical and ion exchange reaction. They are going to react in ion exchange reaction, and in this case, we are going to have ammonium hydroxide and calcium chloride. Calcium chloride. So we are going to have those two products, and of course, calcium chloride is going to be channeled out by following this arrow down here. which tells us that calcium chloride is the only product in this reaction which is never recycled, but it has got a variety of uses. Yeah, it has got a variety of uses, but it is the only end product, or it is among the products that it is among the byproduct that is never recycled. It's never recycled. Yeah, it's never recycled. Now this one, the remaining products, apart from calcium chloride, the remaining product there is ammonium hydroxide in chamber 2, which is being recycled again to start the process in chamber 1. In chamber 1, yeah. So that's how the reaction goes. Yeah, calcium, ammonium hydroxide just recycled, and starts the process in chamber 1. So what are the uses? Because we are saying that calcium hydroxide is never recycled because it has got, and of course it has got a variety of uses. What are the sum of these uses? What are the sum of these uses? Now we can apply anhydrous calcium chloride in rod surfacing to keep the rod moist. It is used in rod surfacing. Rod surfacing. Anhydrous calcium chloride. I'm sorry to write this. It was supposed to be calcium chloride. Huh? Sorry. I'm sorry. That is the correct formula of calcium chloride. It was not supposed to be calcium hydroxide. Just a slight mistake. So the calcium chloride in its anhydrous form can now be applied on rod surface. That means it keeps, because of its hygroscopic nature, it can be used to keep the rod moist. Keeps the rod moist because it absorbs what? Because it absorbs dust. So it keeps the rod moist and dustless. Keeps the rod moist and dustless. Especially on the areas, on busy towns. Areas like the busy town, we are going to have this being applied on the road to prevent dust